Today we will be using the quadratic formula again to solve these equations. So the important thing to remember with the quadratic formula is that we have to isolate this or set it equal to 0. So we have to move everything over to one side. And so that way we can figure out our a term, because a is the coefficient in front of x, squared that is. B is the number out in front of x, and our c term is the last term. It's our constant. So you always set it equal to 0 first. And then from there we can go ahead and solve. So we'll take a look at our first problem here. Got to move this 15 over. So whenever you have a term and you need to move it over, the sign will always switch because you're having to do an opposite operation to get it to the other side. So now we have x squared plus 14x minus 15 all equals 0. So now we're able to solve this. And so we're going to end up using that quadratic formula by substituting the numbers in there. Opposite of b is negative 14 plus or minus the square root of 14 squared minus 4 times a, which is 1. C is negative 15. This is all over 2 times a, which is 1. So we do some work there. We get a negative 14 plus or minus the square root of 196 is what we get when we square that 14. And then here we have to watch those signs. Negative times a negative makes a positive, and that's going to end up making 60. And this is all over 2. So we've got to add those numbers together. So when I do that, I have a negative 14 plus or minus the square root. And when I add 6 and 9, I end up with a 25. And so I get 256 all over 2. Well, when I take the square root of 256, it ends up being 16. So I have negative 14 plus or minus 16 over 2. And when I set up my two problems, negative 14 plus 16 over 2, and I also have the negative 14 minus 16 over 2. So I go ahead and do some more work there. I got 2 over 2, which makes 1. Over on this other side, I got negative 30 over 2, which ends up giving me the negative 15. So those are my two x-intercepts. So you can see the quadratic formula works for every problem. However, sometimes the problems seem a little bit tough because the numbers are big to deal with. So let's take a look at this next one. But sometimes we need the quadratic formula because we won't get numbers like this. We might end up just with a irrational root, which means that we wouldn't be able to take the square root unless we approximated it. Well, this one's ready for us to set up. So here we go. X equals the opposite of b, so positive 2, plus or minus the square root of negative 2 squared, and then minus 4 times a, which is 1. C is negative 2, all over 2 times 1. So we do the work there. We've got 2 plus or minus the square root. This makes 4 plus because the two negatives make a positive. That makes 8. This is all over 2. Well, on this problem, we don't have to take it out as far. I'll just let you leave it just this far right here, because we can't take the square root of 12 without approximating it, and I'm not going to have you approximate the answer, so I'm just going to leave it in the exact term form right now, and that's it. So we'll take a look at the next one here. We're having to move, nothing to move on this one, just got to substitute the numbers in there. So negative 10 plus or minus the square root of 10 squared minus 4 times a, which is 1, and then this time c, which is 9, all over 2 times by 1. Do some work there. Negative 10 plus or minus the square root, and then we've got 100. And then this time we just have a minus sign because it's a negative times some positives there, and minus 36 all over 2. So we go ahead and do some more work. Negative 10 plus or minus square root of 64 is what we get underneath that radical sign. And this is all over 2. So we do some more work there. Negative 10 plus or minus 8 over 2. And then we can set up our two problems. Negative 10 plus 8 over 2. And we have negative 10 minus 8 all over 2. So when we do some work there, this makes a negative 2 over 2, which makes negative 1. Over on this other side, negative 18 over 2, which ends up giving me a negative 9. And those are my two x-intercepts. Well, looking at the next one, we've got our b term is negative 8, so it's going to be a positive 8, plus or minus the square root of that negative 8 being squared, minus 4 times a, which is 1. C is negative 5. And this is all over 2 times a, which is 1. So we do the work there. We've got 8 plus or minus the square root. And here we have 64, and this time it's a plus sign because the two negatives make a positive, so plus 20 all over 2. Well, I'm just going to have you add those two numbers underneath that radical sign together, and it gives us something that's not a perfect square. So we end up adding that, we get 84. Almost 9, just a little bit more, but not exactly. And we're just going to leave the answer like that. It's not a perfect square, so we'll leave it in the exact form for this class. Next problem. I'm going to move this 7x and the negative 3 over. So when I do that, the signs end up switching. So notice that I have to subtract that 7x. That's why it becomes a minus 7x. Add the 3. That's why it's a plus 3. And this all equals 0. And so from that point, I substitute my numbers in there. So the opposite of negative 7 is positive 7, plus or minus the square root of that negative 7 being squared, minus 4 times a, which is 2, and a c term, which is 3. This is all over 2 times by 2. Do some more work there, 7 plus or minus the square root, and then we've got 49 plus because of the two negative signs there. This makes 8 times 3 makes 24. And this is all over 4. So we have some more work to do. 7 plus or minus the square root. Add these two numbers together. Let's see, 9 and 4 end up making 13. And a 4 and a 2 end up making 6 plus 1 makes 7. And so this ends up giving us a number that's not quite a perfect square either. And so just checking that math real quick. We got 8 times 3 is 24. Two negatives make a positive there. 7 squared makes 49. Add those numbers together, and yep, 73. So it's not a perfect square. That's okay. We'll just leave it the way it is. So there is our answer. So we go ahead and, again, the key is if they don't work out as perfect squares, we'll just leave it in that square root form. And if they do, then we have to continue working until we get the two answers. Those are similar problems, which you'll see tonight.